So mass spectrometer and ionization energy pop quiz 23. So in the first question, MCQs are there in this pop quiz. Element in their most stable state exists as if elements are most stable, how they will exist. Atoms in giant structure only, like if they are most stable, they will exist as a giant structure only. No, because if we have different types of structure, we have simple molecular structure, we have giant structures, we have ionic structures are there as well. So atoms in molecule and atoms in a giant structure only. Like what does it mean? It means like simple molecular structure will be there or a giant structure will be there. Isolated atom, when element, because we want how elements can exist, the structure of the elements. So elements can be atoms, elements can be molecules, or elements can be giant structures. Like when we talk about elements to be atom, isolated atom, like helium, neon, argon, these all are atoms. Same thing, they can be stable as a molecule as well, like Cl2, H2, Br2. So they can be molecule and atoms in a giant structure as well, like carbon having a existing as a diamond, graphite, or fullerene. So it has a giant structure. So in element state, when a substance is an element, it will be stable. Its stable state can exist as an atom, isolated atom. It can be a molecule or it may have a giant structure. That's why option D is a valid answer for this. In question 2, the atomic number of the element scandium is 21 and the mass number of its only isotope is 45. What is the number of electron in scandium? So this is the atomic number. The atomic number represents the number of the protons. And if it's an atom, the number of the proton and number of electrons should be equal. But if it is scandium plus, so means it will lose, because positive charge means it will lose one electron. So when it will lose one electron, how many electrons will be there? It will have 20 electrons. So A will be the right answer. In a mass spectrum of scandium +1 and +2 ion, the mass to charge ratio values due to scandium +2 ion. So how we can work out the mass to charge ratio? The mass is given. The mass is given 45. Okay. And we want M by Z ratio. So this will be 45 and the charge is 2 plus. So 45 divided by +2. So 45 divided by +2, it will be 22.5. So 22.5, it matches with option A. Which equation represent the first ionization energy of iodine? First energy needed to remove electron from a neutral gaseous atom, we call that as the first ionization. So first this is a molecule, this is a molecule, this is a molecule. So here we have atom in a gaseous state and we remove electron and it form a positive ion. So D should be the right answer. Because of ionization energy means energy needed to remove electron from a neutral gaseous state. What is the electronic structure of a nitrogen atom? So nitrogen, we have 7 and 14. The configuration is 1s2, 2s2, 2p3. So in a P, how the electron in a box model, like first 1s, 1 clockwise, 1 anti-clockwise, 2s, and then 3p will have 3px, 2p will have 2px, 2py, and 2pz. First they will occupy singly and then they will pair up. Why this is wrong? Because what it shows that they both have the same spin in the same direction, but it's not possible. Two electrons in the same orbital cannot have the same spin. They should have opposite spin, so they overcome the electrostatic repulsion by their opposite magnetic fields. That's why. So this is also wrong. This 1s is correct, 2s is correct, and 2p is also singly they will occupy. So C is the right answer. In 5, the element manganese has an atomic number of 25. What are the number S, P, and D electron in an atom of manganese? So first we write the configuration 1s2, 2s2, 2p6, 3s2, 3p6. It makes 18, then 4s2, and then 3d, 5 are there. They're asking how many electron in s orbital for each of them, like the total number of s. So we have to count like here 2, 4, 6, 8. So in S we will have 8. What about P? 6, 6, so makes 12 total. And what about D? Only one D is there, that is having 5, so D will have 5. So 8, 12 and 5. So 8, 12 and 5, so it matches with option B. So first you have to write the electronic configuration and then work out how many electrons are there in each orbital. Some physical properties of 5 substances are shown. Which of these substances could be a metal? So you have to check the properties. When you check L, it does not conduct, so this cannot be a metal. Good, good, it reacts with water, and melting point is 98. This also electrical, because metal have a good electrical conductivity, so we are left with two parts only. We are left with M and N. So M in solid state it is good, and liquid state it is good, and also solid state it is good. Liquid state it is insoluble in water, means it does not dissolve, and here it is reacting. Metals can react, and when you check the melting temperature is 1083, here the melting temperature is 98. So what this give an idea, because these properties like conducting electricity in a solid state, the two substances which can conduct electricity in a solid state, like it might be graphite, like a giant structure of a graphite might be there, or it might be a metal. So this white cannot, it's not a graphite. Why? Because if you see the melting point is low. Graphite, if it was a graphite, the giant structure, the melting point should be high. So because this property and these two properties does not match with a giant structure, because if it was a giant structure of a graphite, then it should be good and this should be high. But here it is conducting. So because metals, either metal can conduct or the giant covalent structure such as graphite can conduct. So that shows that M and N are could be the metals. Even though the 98 is a low melting point, but as you know about the melting point of alkali metals, group 1 metals, they have a low melting point compared to other metals, and they can react with water to form an alkaline solution. Which substance has a property shown that it changes from a molecular structure to ion when it dissolves? So it has a molecular structure, but it turned into ion. When we check the options, first L, in solid it is not conducting, because they mention here it has a molecular structure to ions when it dissolves in water. Solubility in water is good. And these two are not there. When we M cannot be, because M is already a good conductor. If it has a molecular structure, it should be initially it should be poor. So when we check option P, P remain like P even does not dissolve, so P cannot be. So either L can be there or Q can be there. But for if you see for L, it is not conducting electricity in a solid, but it is conducting electricity in a liquid. So means this is ionic structure, because ionic structure does not conduct electricity in solid, but it can conduct electricity in liquid or molten state and aqueous. Here, so both ways it is not conducting. So this give an idea that it is a covalent structure, molecular structure or a simple covalent structure. And this simple covalent structure does, like in a solid or liquid, it does not conduct, but when it is dissolved here, this one, it dissociate into ion and it start to conduct. So D will be the right answer. So this give an idea, it might be hydrogen chloride, HCl, which does not conduct electricity, but when we dissolve in water, it changes into ions and conduct electricity. In question 7, which row in the table shows the correct forces in crystalline lithium iodide? Attractive force between the oppositely charged ions, that is there. Repulsive force between the ions with the like charges, that is also there, because like charges repel. And some covalent bonding. What some covalent bonding forces are there? What does it mean? Why some covalent bonding forces? Because what will happen? Lithium and iodide ion is larger in size. Lithium is smaller, iodide is larger. As a result, what it's called a distortion to the negative ion. And this distortion to the negative ion leads to some covalent forces as well. Like it appears that they are sharing the electron with each other. They are not sharing, but it appears because of the shifting the electron density, it appears that they are sharing the electron. So some covalent bonding forces refers to like there's a distortion. So if it was isoelectronic, like example, when we say we have sodium is there and fluoride is there. Sodium ion is having 10 electrons. Fluoride ion is also having 10 electrons. So when we have isoelectronic, then there is no distortion and this will not be there. But because this is not isoelectronic, like lithium electrons and iodide electrons are not same, as a result, this will cause a distortion to the negative ion. So they will have both covalent nature, like they will have this is called a covalent nature of ionic compound, or some covalent bonding forces are also there, which appear that they are sharing electrons. So this was a pop quiz which was related to mass spectrometer and ionization energy.